This lecture is going to cover hypothesis tests. Now, what a hypothesis test is, it's a different way to estimate your population parameter. We already saw a way to estimate your parameter through a confidence interval, right? And what a confidence interval did was it created a range of values. And using that range of values, we were able to estimate what our parameter of interest was. A hypothesis test works slightly differently. It makes an assumption about the value of your population parameter. What do you assume that value to be? And essentially now, we use sample statistics to test the validity of that assumption. So it's different from a confidence interval in that we assume something about our parameter. Confidence intervals makes no assumption about what your population parameter is. It's not like one method is necessarily better or worse than the other. They're just two different ways to accomplish the same thing in estimating a parameter. You use them for slightly different reasons, which we'll discover shortly. Let's check out the first step of a hypothesis test. So for every hypothesis test that you do in this class and statistics in general, we have two hypotheses. The first hypothesis is what's called the null hypothesis. You'll hear it called H naught sometimes. So the notation is H subscript naught, that little O or zero. And what this hypothesis does is it sets the parameter you're interested in equal to a specific value. It's the assumption. What do we assume the parameter equals? The second hypothesis is called the alternative hypothesis, and it's denoted as H subscript A. And this sets your parameter equal to a range of values that oppose the null. So there's three different symbols you can use for the alternative hypothesis. Does not equal to, greater than, or less than. And this is essentially what you are trying to prove. I like to think about hypothesis test as like a courtroom, right? For every criminal trial in a courtroom, the person that is on trial, the defendant, the assumption at the start of the trial is that they're innocent. That's the assumption. Think of that as the null. That's assumed going into the trial. The assumption is innocence. So for our statistical test, the assumption is that your parameter equals the value you assigned it to the null hypothesis. Think of these hypothesis tests as us being the prosecutors. We are trying to prove them guilty. We are trying to support the alternative hypothesis. What we are actually interested in is the claim made in the alternative hypothesis, because this is what we'll be able to support based on the amount of evidence we find in our study. Let's check out an example. In this example, suppose I gave you a dice. And imagine we were playing a game where if you roll that dice and it comes up as an even number, you win $1. But if it lands an odd number, you lose $1. So you'd think there's a 50-50 chance of throwing or rolling an even or an odd number. We both have the same likelihood to win or to lose $1. So you start rolling this dice over and over again. And you notice it keeps coming up as an odd number. There's a lot of odd numbers coming up. And you think to yourself, did Professor O give me a fixed dice to try to earn a couple bucks off of me? So this is a scenario where you can use a hypothesis test. The hypothesis for this test is that the null hypothesis is assuming the probability or the likelihood of rolling an odd number equals 50%. That's the assumption. The assumption is that I'm innocent. You're trying to prove or support that the probability of rolling an odd number is greater than 50%. You think I gave you a fixed dice. So in this case, the null hypothesis is that the population proportion pi equals 50%. And the alternative, what you're trying to prove, is that the proportion is greater than 50%. Now this is one set of a directional hypothesis test. We could have something like this. We hypothesize that the population proportion is less than 50%, or 0.50. There, the only difference would be that HA is less than 0.5, or 50%. Our null hypothesis It's still assuming that it equals 50%. We could also try to support that it's just different from 50% or 0.50. It could be bigger, it could be smaller. We just care that it's different. So there's 3 set of directional hypotheses that we can do for these hypothesis tests: greater than, less than, or does not equal to.